At this time, I'd like to introduce our first presenter. Rebecca Peterson is Senior Product Marketing Manager for System Sensor. Rebecca, take it away.
Thanks, David, and welcome everyone. Thanks for taking time out of your busy schedules to join this webinar on intelligibility in notification appliances and Evac. Now let's go over what we will be covering over the next 45 minutes or so. For voice evacuation systems, one of the most significant changes with the 2010 edition of NFPA 72 is the term intelligibility. So we're definitely going to be touching on that. Next, we're going to talk about some of the factors that can affect intelligibility, such as room dimensions and materials, ambient noises, speaker choices, and other factors. After that, we will go over the system sensor speakers and speaker strobe devices that are also part of a voice evacuation system. Then I'm going to be turning it over to Bruce Olson from AFMG Technologies, the worldwide leader in software for pro audio industry, who's going to go over the Evac software tool, and he's actually going to be doing a live demonstration. So this is a great tool if you're going to be starting to design a lot of voice evacuation systems. As David mentioned, you can enter in questions through the chat box on the lower left-hand corner, and we're going to try to answer as many as we can during the webinar, but if not, we'll definitely have time at the end for questions and answers. We have a lot of content to cover, so let's get started. So first, let's take a look at the new intelligibility code. When it comes to notification appliances, there are many choices to select from. You can use a bell, a strobe, horn strobes, or speakers. But the first step into an emergency communication system is utilizing speakers and speaker strobes over traditional horn strobes or bells. By utilizing pre-recorded or live messages, you can provide building occupants accurate, real-time information of what they should do during an emergency event. In some cases, you don't necessarily want occupants to evacuate the building. For example, if there is a tornado in the area, you could direct occupants to move to an inner room. Or if there is a chemical leak, you can direct occupants to evacuate a very specific exit. With notification appliances, we are used to just addressing audibility, which is how loud that message is, and whether you can hear the message over the ambient noise conditions within a given space. This is still a very important term, but with the 2010 edition of NFPA 72, it has included new terminology on intelligibility. The 2010 edition defines intelligible in relation to a voice system as being capable of being understood, comprehensible, and clear. It defines intelligibility as a voice communication of having quality or condition of being understood, comprehensible, and clear. So I always like to relate it to the Peanuts character, the teacher in the Peanuts character, where she's kind of like that, wah, 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 wah. You know, you obviously want your building occupants to make sure that they hear that message the first time and that they understand it and can react without any delay. We are talking about life safety systems where time is precious. So what is driving intelligibility? Well, voice evacuation systems are growing in popularity and required in more areas. That is especially critical for buildings where you have to manage the evacuation of complex building layouts, such as high-rise buildings or large areas of assemblies. In addition, many states and regions are moving to the 2012 edition of the International Building Code and Fire Code, which indirectly references the 2010 or the 2013 edition of NFPA 72. As I mentioned earlier, with the 2010 edition of NFPA 72, intelligibility became a key term that can and may be enforced within a design. For any of you that do work with the military, you should be familiar with UFC 4-2101, which also refers to the definition of intelligibility based on NFPA 72 2010, and has required measured intelligibility for voice evacuation systems for many years. Now, another important term added to the 2010 edition of NFPA 72 is ADS. ADS is an acoustically distinguishable spaces. You'll be using this a lot if you're designing voice evacuation systems that need to meet intelligibility to the latest code. NFPA defines an ADS as an emergency communication system or notification zone or a subdivision thereof that might be enclosed or physically otherwise defined space that can be distinguished from other spaces due to acoustical, environmental, or characteristics such as reverberation time or sound pressure levels. So that's obviously very wordy definitions, but all they're really trying to say is that they're areas that are defined either by enclosures like walls or doors, or that have like different properties of ambient conditions. The code defines ADSs within Chapter 18 of NFPA 72, which is the chapter for notification appliances for protected premise fire alarm systems. So now let's take a look about who identifies ADSs and how they are used in the design of an actual voice evacuation system. So first, it is the system designer of the voice evacuation system or the emergency communication system who determines how a space or facility should be broken down into specific ADSs in the planning phase of the project. So not after the construction has been done, it's during the planning phase of the project. The designer also determines if intelligibility is required in each distinct ADS, and of course when or where required, the code always makes allowance for the AHJ to review and approve once the plan is completed. Typically, the designer will segment the building or space based on physical barriers such as walls or doors. There may also be changes in materials used on the wall or the ceiling or floors, or changes in expected ambient sound levels for that space. Once these designations are made, the designer will then decide if each specific ADS should and will require intelligibility in that space. Same factors that drove ADS designation will come into play here. For example, if an expected ambient noise level in the ADS will be virtually impossible to meet intelligibility, then the designer can decide that ADS does not need to meet intelligibility. This approach avoids costly over-designing of voice evacuation systems, especially in areas that are impossible to meet intelligibility. In this case, the designer may decide to use a different type of notification appliances to meet the code, such as, just as an example, a strobe. Another potential is if intelligibility is required, but you might not necessarily want to measure within each ADS. In this case, testing may be required, but it's not practical to necessarily measure every space because it's pretty clear that the message is clear. An example of this is a hotel room where it's pretty small and you know that you're going to understand that message once it's played. So these requirements drive the intelligibility process, which can be broken down into 4 main steps. So the first step, the ADS are assigned by the designer. If intelligibility is not required, then the process is complete for that area. If it is required, then the designer needs to decide if he's going to be actually measuring intelligibility in that space. If he is going to measure it, he needs to determine whether he's going to be using subject-based methods or objective-based methods. For subject-based methods, they typically involve using a group of trained listeners that are actually going to listen to that voice message and determine whether it's intelligible for that given space. If objective methods are going to be used, then you're going to use an actual intelligibility meter, which I'm sure many of you might be familiar with. It measures intelligibility of a voice message against an objective scale, either STI or CIS. Okay, David, I think it's time for our first poll question.
You are correct, Rebecca. Thank you. So we're going to serve this first poll question up. So just curious, can you tell us when do you plan to specify or install an emergency communications or voice evac system? Some of you may be working on that now. So click currently working on a project. Maybe you have some project outline in the future, 6 months, 7 to 12 months, 13 to 18 months, or more than a year and a half out. Or perhaps you're part of that AHJ or building official that do not install or specify. So go ahead and give us a response on that. We have nearly 400 people online with us, so we would appreciate you voting when these poll questions come up. Rebecca, there was a question posted earlier. What are the requirements for a systems designer? How would we respond to that?
You know what? When the 2013 edition of NFPA 72, they have added, I'm not exactly certain if it's requirements or guidelines for what a personnel should have in terms of qualifications. I believe it's defined in section 10.5. But I can always double check that after the webinar and get back to that individual.
Very good, very good. Okay, so I'm going to go ahead and close the poll. Thank you for voting. As I mentioned, we'll only spend a few seconds on each of these poll questions. So Rebecca, it looks like about 42% are currently working on a project. So that's great. Another 15% C1 in the coming months, and about 19% do not install or specify. So Let me cue up the next section. And Rebecca, back to you.
Thank you. So next we're going to take a look at factors and key drivers that can influence intelligibility within a space. There are several factors that can play into intelligibility of a voice system and characteristics of a system. Several of these characteristics can be changed or designed around to improve intelligibility. First is the signal-to-noise ratio, which is simply the output of the speaker compared to the ambient noise levels of that particular space. The higher the ratio, the greater the intelligibility. The characteristics that drive the signal-to-noise ratio are the speakers that are being used, the type of speakers, how are they spaced, the volume or the tap setting that they are set at, and of course the ambient noise levels of that space. Another factor are echoes and reflections within that space, also known as reverberations, which are related to how sound waves bounce off within the given space. Big contributors are room materials. So when you have soft, plush carpeting or curtains, they tend to absorb the sound waves as compared to hard surfaces like tile floors or marble floors, which will bounce off the sound waves. Speaker placement has a lot to do with echoes and reflections, which has a major impact on intelligibility. And most times, unfortunately, the system designer has limited control over this, since these are part of the building construction or the architect's design. Beyond the physical characteristics of the room and voice system, the human factors have contributed an effect to intelligibility. For example, the individual's ability to speak into a microphone in a clear and understandable manner, whether it be live or pre-recorded, can have a large impact on intelligibility. Human factors such as accents, dialect, whether it's a male or female voice, the frequency or speed of that voice contributes to the talker ability. Likewise, the listener ability or the sensitivity of the listening ability also plays a large part into intelligibility. Hearing ability and the ability to focus on a message can impact this greatly. As we age, we tend to lose hearing across the frequency range, and this can really impact a person's ability to understand that message. The last two factors we're going to talk about are related to the delivery mechanics of that voice message, or more to do with the hardware, so the speaker and the audio equipment that is being used. Frequency response is a quantitative measure of the output of the device in response to a stimulus. A speaker's frequency response indicates how much of that range of a speaker can closely reproduce that original voice message. The closer the speaker can match the original recording, the more intelligible and natural the output will sound. Ideally, voice evacuation speakers should have a wide frequency response. The wider the response, the better it is at reproducing the signal that was introduced into the system, which obviously will provide a better opportunity for it to be understood. The frequency response should be as flat as possible, so not very considerably. So that means that you shouldn't have a lot of changes in inflection on that voice message. It's important to know that UL 1480, which is the standard for fire alarm speakers used for voice evacuation systems, requires that speakers be listed at a minimum range of 400 to 4,000 hertz. The last factor is total harmonic distortion. This is another key factor that can affect intelligibility. Audio signals suffer from distortion as they pass through the electronic circuits. The distortion can be introduced by various components in the voice evacuation system, and the effect can be cumulative. Systems designed with low harmonic distortion tend to provide voice messages that are more intelligible. Distortion can be caused by damaged speakers, if you're overloading your amplifier circuit versus the available power, the speaker installation, incorrect wire size, and message generators or recordings. Now, we've pulled some information from our low frequency adoption map. If you guys are familiar with that map, this is in essence tracking what states and regions are following the 2012 edition of the International Building Code and Fire Code. So these lighter blue states are the ones that have whole state adoption. As you can see, we're sitting around 22 states that are following the latest code, so they might be enforcing intelligibility. I know, for example, California has now, they're adopting the 2013 edition of NFPA 72, and they are enforcing measured intelligibility. States that are in the dark blue are ones that have local or county adoption of the latest edition of the code. And if I put the two different color codes together, we're sitting at about 35 states that are following the latest code. So they might be requiring intelligibility. Okay, well now that I've addressed the factors that can affect intelligibility, let's take a look at System Sensor's Spectral Alert line of speakers and speaker strobes. System Sensor provides a full line of speakers and speaker strobes that are ideally suited to meet intelligibility and audibility requirements for voice evacuation systems. We have two lines. The SP line, which is our high fidelity line, provides richer fidelity, which is perfect for crisp, clear messages. We also offer the SPV line, which is our high volume line, which produces about 3 dB output more at each tap setting compared to the high fidelity line. These are ideal for areas where you have higher ambient noise conditions or where you may just want to use less speakers to get more sound output. These devices use a universal mounting plate with an onboard shorting spring, which ensures wiring continuity before the devices are ever installed. So the installers can verify that you have your proper wiring without actually having to mount the device and prevent damage during construction. Our Spectral Alert Advanced line of speakers take less room in the electrical back box and are one of the only products in the market with a plug-in design. This really minimizes the ability for pinched wires during installation and timely chasing down of ground faults. We also offer accessories if you need a little bit more room in that electrical back box. And finally, we offer field selectable settings. This includes the candela for the strobe, the speaker voltage settings, and the tap settings. The devices will automatically adjust to both 12 and 24 voltage settings so that the installer can easily adapt the products to meet a wide range of applications. We also offer a full line of outdoor speakers and speaker strobes that are NEMA 4X rated in case you need to use them in non-environmentally controlled areas of the building. Okay, David, it's time for our second poll question.
Very good, Rebecca. Thank you for that. Yes, we do have a second poll question here, so if you can address this question on your computer at this point. So for a voice Evac system, how frequently do you need a 4-inch or larger speaker that is tapped to 2 watts or larger? So again, 4-inch or larger speaker that's tapped to 2 watts. Are you running into that frequently, maybe nearly every project that you do because of the type of projects? Infrequently, rarely, or never? Maybe in your history of working with these kind of voice Evac systems, you've never come across that. And again, we provide that option for do not install or specify. So if you could go ahead and respond to this poll question, we'd love for all of you to vote. We will take a question at this point too. Let's see here. There's a couple questions, Rebecca, about the intelligibility meter or an instrument for doing that. Where could they buy something like that, and is there one that we might recommend?
There's a few manufacturers that make intelligibility meters. I know of 3 in particular. Goldline is probably one of the most popular, and I believe you go under goldline.com. 3M also makes one that's called Quest meters that we tend to use a lot internally just for validation testing. And I have learned that recently SDI, the manufacturers that make that can smoke, they partner with Embedded Acoustics and now have an intelligibility meter and a talk box and a number of other products for intelligibility.
Okay. All right. Very good. So let me go ahead and close the poll. Thank you for voting again. We're just going to spend a few minutes or a few seconds really on each of those. So looks like, Rebecca, the feedback is more than half are saying that pretty infrequently or rarely, 52% in fact indicated that they don't run across that requirement for the larger speaker, which is 2 watts or larger. So great. At this point, we're going to transition. We're going to invite Bruce Olson to join us. Bruce is the technical support leader for AFMG. AFMG is the manufacturer, the creator of Evac software. And again, as I noted earlier, there is no financial affiliation with System Sensor and AFMG. We've located these guys, and we realize that they are important in this market. So I'm going to turn it over to Bruce. Take it away.
All right, thank you, David, and thank you, Rebecca, for all that great preliminary information about intelligibility. We're going to be talking about how we can use software to deal with a lot of the intelligibility factors that Rebecca just talked about. So first, a quick overview of what Evac is. It provides an intuitive tool for designing acoustic mass notification systems in a room, hall, or building complex. The 3D simulation software calculates the distribution of direct sound levels as well as the total sound levels, the signal-to-noise ratio, and speech intelligibility, whether that is STI or CIS. Features intuitive room entry in just a few minutes, and we're going to take a look at that in just a couple of minutes. Precise prediction of both SPL and STI, or audibility and intelligibility. Loudspeaker data for many of the leading brands, especially including System Sensor, the Spectra Alert line that Rebecca just talked about. It also creates extensive reports for calculation, presentation, installation. Calculation engine of Evac is based on EASE 4.4, the industry standard for electro and acoustic room acoustic modeling. So it has value for three distinct groups of users. The first one is the design engineers that Rebecca spent quite a bit of time talking about. Allows those designers to address design systems early on in the design process. It takes a look at handling from the list of intelligibility factors, the first two and the last one, as far as looking at audibility, intelligibility, and some of the factors of loading of amplifiers and so on. Meets the NFPA 2010 and 2013 codes, allows for doing this modeling and pre-testing in a virtual environment, which can help limit costly design changes and also help to make that decision about ADSs as to whether or not the noise levels in the room are high enough that it's going to be rather difficult to achieve intelligibility without spending all of the money that's in the bank. The second group that it's useful for is the AHJs themselves. It gives you a good way of providing documentation to them about what the expectations are for the systems that are being designed, and it allows you to reveal potential problems that maybe had not been seen before that time. The third group that it's important for are the building owners themselves. It allows them to see the opportunity of non-code compliant systems that might delay commissioning and prevent the building from opening on time. It raises confidence in the intelligibility that is going to be available during an emergency, and again allows them to see problems early when decisions can be made to about what the systems ought to be. So now let's take a look at the software itself. Give me just a second here to switch my screen over to the EASE Evac application, and then we'll take a look at walking our way through a project. So hopefully everybody can see my screen now and see EASE Evac open to the default project.
We can. Thank you, Bruce.
Very good. Thanks, David. So this is the default screen that comes up when you open the project. I'm going to label this webinar for the project in the project title. Across the top, we've got a menu bar that allows you to open and save projects, to do some reports and a variety of other things we'll look at a little bit later on. A couple of other menus that are related to editing the project and then viewing various parts of the project. We'll come back to all of those as we go along here. The author and company has been automatically pre-filled in for me. That comes from an options setting in the options dialog box. You can also change it for a specific project directly here. It also has a large notes space that allows you to write down notes about the project, what set of drawings were used, what the design assumptions were, whatever general notes you need. That is saved with the project and can be recalled later on when you open up the project after a period of not being involved with the project. Along the bottom of the screen, we have a number of tabs that step us through the process of creating the project. So the first one that we'll take a look at is the Room tab, and this shows us the settings for this specific room in the project. We can have multiple rooms. We'll look at that in just a little bit as well. Here I'm going to call this just the default room for this webinar project. It has a room height that I'm going to set to 8 feet. It has an ear height. This is where it's going to do the mapping of the system, and that's set for 5.6 feet. As a default, both of those are also in the options. 5.6 feet is a standing ear height and is typical for voice alarm systems. You also might use a 4-foot seated height for conference rooms, hotel meeting rooms, and things like that. The next thing is you can choose the network voltage that's going to be used. This is the amplifier voltage that will be used in the system. Here I've set it to default to 70 volts for North America systems, but you can also select 25 volts or 100 volts if you're working internationally, or a variety of other voltage systems. Next up is the noise settings, where we can choose to import a variety of different noise settings. We have some predefined noise values, A-weighted values that are described in the annex of NFPA 72, and you can load those in directly in order to see if noise is an issue with your project. Here I'm going to bring in an A-weighted 40 dB SPL level and use that. The next thing is the reverberation time. The reverberation time can be calculated two ways. One way is to import a reverberation time that you may have measured for an existing room, or if you are designing before the room exists, the program will calculate that reverberation time for you, and we'll look at that in just a moment. So in the drawing area over here on the right, this allows us to redo the size of the room by selecting a vertex and simply drawing it to a appropriate size. Here I'm going to reduce the height and the width of this room a bit, and then I'm going to also reconfigure the room to add an L-shaped section at the upper left here, and I can do that by first dragging this vertex, and then I can grab vertices in the middle and drag them around. So it gives you a very quick way of drawing a room and getting it set for the size that you need. So now we have a nice room. The next step up is to take a look at arranging these ceiling loudspeakers that we have. Right now I'm choosing from the system sensor database, where we have both the SPC and SPV products, with and without strobes and with and without I forget what the other one is, strobes and SCs and SPS, so on in both versions. So right now it's automatically arranging these. I can see that I'm starting at the edge, so I'm going to offset this a little bit, move that over by 5 feet here. And now this will automatically rearrange all of the ceiling devices in the system, given either a square layout type or a hexagonal layout type, and then I can choose various different types of overlap between the devices. Most often we use edge to edge in voice alarm systems, or I can set a specific distance and say that I want to set them all at an 8-foot distance, and then it will recalculate the spacing for that system and allow us to see what the result is. If I'd like to add additional loudspeakers, I can also do that by selecting the Add Loudspeaker icon at the top of this window, and then I can drop in additional loudspeakers as I believe are necessary. On the Sound Source tab, this allows us to see all of the devices that we've added. We can select devices in here, we can remove them, we can move them around, and the list on the left shows us where all of those devices are. Currently I'm showing that I need a total consumption of 5 watts capability in my amplifier. There are 19 devices. They all happen to be an SPV. I can choose to change groups of these devices separately. Here I can choose a group of these devices and change them individually by selecting the properties for them, and I can change these all to the standard SP device instead. and I can change the height of those and separately adjust those. So now it shows me that I have two different devices that are being used and the total sum. Next part is to take a look at the surface definitions, and here we see all of the walls that I've entered into this room and the floor and the ceiling as well. When I select each of these, I can now apply a material to these. On the floor, I'm going to, this is a conference room, so I'm going to add some carpet, commercial on concrete, apply that applies that material to that floor. Then on the ceiling, I'm going to put in a suspended ceiling, and for each of the walls, I'm going to make them a gypsum board wall. So I can select that from our database here and apply that. Now I've applied materials to the floor, the ceiling, and each of the walls in the space, and I could do that individually as well. Now that we've done that, we're able to take a look at the mapping. I'll turn on the mapping first, and then we'll switch this from no weighting to the typical way that we measure audibility, which is a SPL A-weighted. And now I can see here the predicted sound pressure level or the audibility of the system. On the right-hand side, you see a scale that shows what the levels are according to their colors. You can see here where I changed the type of a device from the high volume that the rest of them were to the low volume, that I have lower volumes in that part of the room, even though these devices are mounted at the same level. And I can then also in this view move things around to fill in the spacing better and adjust these manually if I like to, just by clicking and dragging. If I'd like to have a specified SPL range, by default it automatically chooses the levels for the devices in the room, but I can also fix that by selecting the SPL list over here on the left, or on the right, sorry. So next, now that we see that the levels are in a useful range, let's take a look at what the STI is for this room. And here we see that we've got values that are extremely good. We've got a large number of devices, and they are covering the room quite well. If I switch to my distribution graph here, I can see that I've got an average STI of 0.89, extremely good, with a very low standard deviation. If I take some of these devices and start deleting them, so I'm going to grab a group of them here and delete them from the room. And when I do that, we'll see if we've got any change in the intelligibility. I think all of my levels are so low that everything is good. Let's go back and see what happens if I make this instead a 12-foot high room. Now it's going to recalculate things, and you can see that our STI has gone down. If I change the room height to 16 feet, it still goes down, but it's still good. Let's try 20 feet. So in this room, I've got a low enough reverberation time that I can practically do anything in here. But what this points out is that the program gives you a very quick way of evaluating different scenarios and seeing which ones are going to achieve the kinds of results that you'd like to have. So I'm going to save this room, and then I'm going to move to another room that I've stored already and open that one up and show you some more advanced features. So here I have the 104th floor of a tower. We'll open that up and take a look at it. I'm going to turn off the mapping at first so that we can see a better view of the rooms itself. Here is a number of rooms that I've already drawn in for this 104th floor. In this case, I've got a background drawing that has been brought in. They are the same between the floor map and the ceiling map. I can choose from a variety of different maps for the background map. In this case, this was an AutoCAD file using U.S. architectural units, and it brings it in and it's automatically scaled for us. We can also bring in SketchUp files in addition to AutoCAD files. We can also bring in ease files itself and load those in. And in addition, we can also do images. If we bring in an image, here is a small room. If I bring in that image, then what I need to do is I need to scale that drawing. I can do that by dragging these two A and B items here to the corners of the room. And if I then scale that and say that the distance between point A and point B is, say, 50 feet, this will then bring in the drawing and automatically scale it as a background. I'll do that here, bring it in. If I switch between the two, now I see that background drawing in here scaled to be that size. Let's go back to the map that's correct for this drawing and switch between the various rooms. I have some quick keys that allow me to move through the rooms. First, the left side, okay, and then if I go to the second room is the center corridor. That will zoom me into that corridor. And then the third room will bring me to the mechanical room on the top. The fourth room is over here on the right-hand side, and so on. And then the maintenance room. So now if I wanted to add another room to this project, I can zoom out with my mouse here, and let's come down and add this conference room down here at the bottom. I can choose to add a room by drawing with a rubber band around the room. So here I've chosen the rubber band tool, and now I'm just going to simply draw around the edges of this room like this. And when I get back to the beginning, it is going to highlight the room and turn it all white to indicate that I'm now going to complete that room. And when I click the button over that original room, it now adds this new room. It's called room number 6 by default. It's the 6th room in the project, and now I'm going to call this the conference room. It has automatically put some devices in there. If I change its room height down to an 8-foot or 9-foot height of a typical conference room, then it's going to automatically lay out the system for me. I can decide here I want to add a couple of more speakers down here, and now I'm done with that room. Next thing that I want to show you is taking a look at how do we add wall devices into a room. So I'm going to select this room over here on the right-hand side where I've got a couple of wall devices already mounted, and I'm going to add another couple of devices on this wall in the upper side here. So if I select that wall and highlight it orange in the drawing, and then look at the front view of that wall, I'm now looking at this wall from standing inside the room. So now I can come down to this front view and choose Add Sound Sources, and now I can add a couple of sound sources here. This dotted line that I have is my ear height, and so I know that my 80-inch height is just above that, so I'm going to put a device here, and I'm going to put a device over here. Now, once I've done that, I can select these two devices up here in the plan view by drawing a rectangle around them. Once I've chosen them, I can set their distance from the floor to be my 80 inches or 6 2/3 feet. And I can then also adjust the tap settings for them and let's say put them at 1 watt. And now these devices, if I zoom in on this, I can see that perhaps I'd want to move this device. I can grab it in the plan view and move it along here. And I can move this one as well, and now I've added wall devices into this system. So now we can see, if I look at sound sources, that in this room I have a total of 4 wall devices. I then want to go and select the appropriate wall devices for my type instead of the ceiling devices that I've currently got here. All right, so I think I'm coming to near the end of what I wanted to do. Oh yes, there was one last thing. Looking at the room, I said that we'd calculated the reverberation time automatically using the program. So if I look at this room and go to the settings, by putting in the materials in this room, this has now shown me what the reverberation time is for this room in a graph, as well as individual one-third octave settings over here in a table. I would also be able to import those reverberation times if I had a measured system, or I can export these as part of a separate report or be able to use them in additional rooms. The last thing that I wanted to show you is our reporting capability. From each of these projects, I can create a print version of the report, either as a PDF file or as an RTF file that you can open in Word and then add your own information. You might explain some of the metrics and so on. Here I'm just going to create a PDF report. It's going to go off and create this print version and then open it up in Adobe Reader so that I can see each of these areas of the report. So here we have the project information. If I'd entered some notes, that would be listed here as well. I've used 17 SPVs, 1 SP, and 3 SPCs in the total system. The rooms that I've drawn are shown here. Then for each of these rooms, I can look at the individual room and look at the summary, the room layout, the reverberation time for that room, and then how many sources were used in that room. If I turn on the mapping and do the report, now I'm looking at an STI report, and we'll let it calculate here a little bit. If I now create a report from this system, will give me another report here. We'll open that one up. And now we see in the report the distribution for this room in the center or this room on the left-hand side, what the distribution for the STI, the average, and the standard deviations, and so on. So it gives you a very complete report summary, allowing you to report to the authority having jurisdiction, or to the owner, or to other people in the design team, and so on. One last thing is that we can also then export any of these rooms, and we can export them to CAD files, SketchUp files, or EASE project files. All right, with that, I'm going to turn it back to David. I think we've got another question. Or wait, no, we've got a little bit of review before I do that. So EASE review, we can do design pre-planning, avoid surprises at the end of the job, do things when it's less costly to make changes. We can document the job for the job file or for the authority having jurisdiction. We can avoid system pre-testing where that was required by using design to replace that. This report can then also be used by the installers for setting the tap settings and so on. And the EASE Evac is available through our website, through a store. You can see more information and a variety of different screens, and also download an evaluation version from our website shown on the screen here. Technical support is managed by myself in the North American region with a couple of colleagues that provide support during business hours. You can see our support email there, as well as our North American toll-free number. And then some additional online resources are at System Sensor, where they have some downloadable speaker reports. You can also download this software from there, and it has a number of other brochures. Here, I think I'll turn it back to Rebecca and David to finish up and take us to the last survey question, I think.
Yep.
Thank you,
Rebecca,
Bruce.
is there anything else you wanted to add on the online resources on the System Sensor site?
Yeah, so just one of the key documents that you might want to take a look at is the Voice Application Guide. We just released an updated version last week. So it has a lot of information in there about what does the code require, ADSs, intelligibility. It's just a really good resource guide about voice applications and voice systems. We also have 2 product brochures. our general AV brochure that has all of our product offerings. So that's got chimes, horns, strobes. But the ECS one has specific products for voice systems, speakers, speaker strobes, any products that we might have with the amber lenses, the housings marked alert. So really good resources there. I just wanted to summarize real quickly everything that we kind of talked about here, just to kind of close things up here. So obviously, NFPA 72, the 2010 edition, really did incorporate a lot more information on intelligibility within the body of the code, just so that everyone's aware of that. Prior to that, most of that information was in the annex, so it wasn't necessarily required. It was more of, hey, if you want to look at intelligibility, it was more of a, here's how you might want to do it, but it wasn't required. As more states are going to the latest edition of the code, you may be required to meet it, and you might have to actually measure it. So it's a big drastic change for fire alarm and voice evacuation systems. I did review, obviously, some factors and characteristics that can affect intelligibility. So hopefully you're aware of those as you're looking at designing your voice system. You can keep those in mind and see if they're going to affect your final testing. I went over our system sensor spectral alert advanced product line of speakers and speaker strobes. I've got our high fidelity line that has higher fidelity, so crisper, clearer messages, as well as our high volume line for those ambient conditions that are a little bit louder. And lastly, I really want to thank Bruce Olson from AFMG for providing great resource here with the Evac software tool and walking us through that demo. And I think, David, we can go into Q&A.
You bet. You bet. So one last survey question, and this is actually not really a survey question, but it's more of a how can we help you. So is there something that we've covered today that you'd like more information on? We'd love to send you some of these resources. So Rebecca mentioned a couple of them, the AV brochure or that voice Evac app guide, or we also have a white paper on intelligibility. Perhaps you'd like us to resend you the link to the Evac software. I know Bruce has mentioned in a prior discussion that they do offer a free trial with that. There is a cost to this software. A couple of you have asked a question about that. Looks like, Bruce, it's around $770 US. Is that right? $770 US, if I'm not mistaken. So
I believe
there is a Yep. Okay. And a couple people have reported that as well. They've already visited your website and checked that out. So, but they do offer a 30-day free trial, so we encourage that. So if you'd like a link, but also if you perhaps need a callback. So maybe something Rebecca has mentioned about AV devices you have another question on, you'd like a person from System Sensor to call you, or even you'd like a call from Bruce or one of his colleagues at EasyVac about EasyVac. So check any of those. We're going to leave that up for a couple minutes, but only a couple minutes while we're answering Q&A, and then we'll go back to a couple of those resources pages as well. So Bruce, there's many questions actually about EasyVac. So if I could put you on the spot here. The question that has come up a couple times is, can you import VisioCAD or only CAD by Autodesk? What can you import? A number of people have been asking what type of files can be imported into EasyVac.
So for AutoCAD drawings, they need to be in the drawing exchange format. That is, we can't import the drawing files themselves. It needs to be saved as a DXF drawing in AutoCAD. For VisioCAD and lots of other flavors, MicroStation, whatever it is that you might be happening to use. The other day we had a question on a Revit. For all of these, it's all the same. You need to export those as AutoCAD, DXF, drawing exchange format files in order to be able to import those. And that is also the export format that we do.
Okay, all right. A question related to that, and perhaps you've answered it, but I just want to be clear, this person's asking a very specific question. So after you import something, do you draw around each of the rooms as you demonstrated with your, I think you called it your rubber band tool, or can you just select the walls and it will automatically draw?
That's a great question. It's a feature high on the list for updates sometime in the future. Right now, we only bring in AutoCAD and SketchUp files, and ease files for that matter, as though they were images, that they are just backgrounds, and then you need to choose to draw around them. We do have a number of feature requests to be able to select items in the AutoCAD files themselves and convert them automatically to walls. As of yet, we don't have that, and we don't have a time frame for that as well either.
Okay. All right. A couple questions related to the acoustic material options, and they're specifically asking, can they add custom acoustic materials to the database?
Yes and no. It's yes because it is an open database. It is in our EASE material database format. EASE Evac does not have a way of modifying that database, but if you have EASE yourself or if you have access to somebody who has EASE, then it's a rather straightforward and very simple method for them to create new materials. You can also send in a request to support that for specific materials. If you have a link to a specific material, we'd be happy to add that to the database. We're interested in what we have as a subset of the EASE database in EASE Evac, but if there are some things that are really important, send us an email to support, and we'll get those added to the database as well as sending you a material that you can use for that.
Okay, so last call for the how we can help you. So if you haven't responded to that yet, please do. We're going to be changing it back to the resource pages here in just a moment. So Bruce, I think it's back to you. We got a lot of questions on EASE Evac. So when drawing, so this question is, when drawing, can the program be forced to constrain the lines to 90-degree angles?
No, they can't at this point. Again, that's high on our feature list to add. They can be constrained by, what I didn't show is the list of vertices that's shown on the left-hand side in the room layout. You can edit each of those vertices, and so you can edit those to be very precise dimensions if you need to clean up the drawing. It depends upon what the output goal is. If you're interested in getting a good design, then this is kind of like horseshoes where close counts. But if you need to do a very nice report where you'd like to have your lines matching with the background drawing, then certainly you can touch that up using the table that's on the left-hand side in the Room tab.
Okay. Looks like a couple folks have different versions of EASE. In one case, the question is they have EASE 4.4, and they're asking, does EASE 4.4 include the EASE Evac functions?
Yes, and I see a variety of questions there, both EASE Junior, EASE 4, EASE Standard. All of those are EASE 4 versions that are the big brother to this. No, they do not include the EASE Evac functions that we looked at as far as room drawing and so on. It's a different drawing engine. Actually there, when we import AutoCAD drawings, we do actually turn those into real items in the drawing. It's far more complex software and a bit of a steep learning curve related to that. We do classes on it. It does use the same speaker data, however, as EASE Evac. So any of the devices that are in EASE Evac and any of the devices that are in EASE can generally be used in either program. EASE also calculates STI. It does not have the nice automatic layout of ceiling devices. But because we can export to EASE from EASE Evac, then you can start the design in EASE Evac and then port it over to more complex room. For instance, if you're doing a mall area where you need to do all of the storefronts as some sort of automatic layouts, they might be wall or ceiling, and then you've got the large spaces in the middle of the mall where you'll need a little bit more sophisticated program than EASE Evac to lay those out.
A couple of people have asked about CEU certificates. I had sent a chat on that. CEU certificates will be issued by end of day to the email address that is registered for this webinar. So if you've attended, you've logged in with your email address, you will be the recipient of that. Please check your spam folder. For some reason, some of these end up in a spam or junk folder along the way as well. Back to the payment for ease, is $770 a one-time or a yearly payment?
That is a one-time payment. We sell the software. We do not have a yearly maintenance fee. When we go to a major version upgrade, that is in this case Evac 2, then we will likely charge an upgrade fee for that. But it's not a subscription like Autodesk and other folks are doing.
Okay. All right. Do you support multiple languages with Evac at this time?
Evac is currently only in English. Ironically, most of our German customers, given that we're a German company, are wondering why we don't do it in German, but we don't yet. Someday in the future, we will probably add languages.
Okay. All right. A couple questions on exporting files and the type of files that can be exported, and specifically this one's on AutoCAD. Can you convert or export to AutoCAD?
Yes. So you can export to AutoCAD. It creates a DXF file, and then it can be used. Typically what I do is I then bring that in as a block into my main job program and use it as a background. You can split it off, and it will bring in the speaker locations and the actual wall locations that you used, and you can decide which of those are going to be shown in your AutoCAD drawing then.
Okay. I think we have time for one more question here. This is an interesting one. I haven't seen a question like this before. So if a facility is using electronic sound masking, will that affect intelligibility and thus affect these calculations?
That's a great question. I haven't gotten that one before either. Yes, it will. In fact, what you would want to do then is for a masking system, you have got a design criteria that says what that level is going to be for the masking system. You would then be able to import that as a noise level, whether you measured it or you knew what the actual values were, and then the software would tell you what the result would be with regard to intelligibility. Hopefully the masking is being done in an area. If it's a well-designed system, the masking level should be such that the intelligibility is pretty good, but one of the reasons for masking is to reduce the crosstalk between cubicles and so on. So there's a very fine line that needs to be tread between those two systems.
Okay, very good. We are at the top of the hour, folks, and we promise to keep this to an hour. We respect your time. So to Bruce and to Rebecca, thank you so much for the presentation. Thank you for joining us today. On behalf of System Sensor, we do want to thank you, and as a follow-up, we'll send you a brief survey and would appreciate your help in filling that out. We'll also fulfill those items that you've requested if you did respond to the how we can help you slide. Again, thank you for joining us. This does conclude our webinar. Please have a nice rest of the day.
this every day, I'd get pretty good at it. Remember to turn off the ringer on that phone. But this was the better one that's going to ruin the recording.